All right, here we go. So what we're learning today is a topic, a concept we have to express mathematically. But it is something that I'm sure you guys have done or noticed. It's just noticing a pattern. So when I was young, we'd go on long road trips to go see my grandparents. When I lived out in the Mojave Desert, we'd take trips to LA, and eventually we moved there. But on the car rides, I would play a little game where I'd start with 1, and I would double it, multiply by 2. What do you get?
2.
Multiply that by 2.
4.
Multiply that by 2.
8.
Multiply by 2. One more time.
32.
And again.
64.
64. Keep going.
128.
Keep going.
26.
Keep going. Keep on going. Keep going.
2048.
One more time.
4096.
One more time.
8192.
Keep going.
16384.
More.
32768.
We'll stop
Dang
there.
it.
That was good.
Keep going. Keep going. Keep going.
No, we'll stop.
No.
So I wasn't that good when I was 7 years old. But this is something that what I didn't know. And there's a lot of things with math that you'll just learn. You've already thought it before. You've already thought it or you could see it. But you don't know the terminology. Geometric sequences are just a series of numbers that are multiplied by the same number every single time. There's nothing super hard about it because if you know your starting term, you multiply it by another term or by what's called our common ratio, the value that we're multiplied by. To get to the next term, and you do it with the next term, multiply, next term, multiply. So I want you to just make a little note that everything for today, when we're doing geometric sequences, is multiplication. And you want to make sure you're not doing arithmetic sequences, which are adding. Don't confuse those. We're doing multiplication, geometric. Okay. So looking at this geometric sequence, and the terminology that you'd read in a math book here is just each new term is the product, the multiplied answer of the preceding term and a common ratio. So first off, this common ratio is going to be multiplied from each term to each term to each term to each term. Sometimes you'll just be given a series of terms, and you'll have to figure out what the common ratio is, and that's not very hard. That's one thing we have to do. It's like one skill set. And we also have to know some terminology. The terms are always denoted by A, and it's a sub 1. This is an exponent. It's just denoting that this is the first A, the first term. So 4 is A sub 1, 8 is A sub 2, 16 is A sub 3, blank is A sub 4. So what would we need to know, even if you're just processing it through mentally, what do we need to know in order to find what comes next in here? What are just some things we need to know? Who's the best guesser in here? Who is it? I'm going with Evan. You're the best guesser. And it's right. Who has an idea what goes there? And then I'll break down your process. What goes in here?
What?
32.
We're multiplying. How do we go from 4 to 8?
2.
Multiply by 2. Multiply by 2.
32.
32. Hey, it's okay. Taking a guess. So if you're surprised you didn't get it right, I'm going to show you the process to get it right every single time. It really is very straightforward. Now, the thing we have to do is, what is the ratio? Some are able to see the ratio quick. It's multiplied by 2, multiplied by 2, and so on. But if you can't see the ratio, there's a real quick, easy way to do it. All you have to do is to find the ratio. You take the term and divide it by the preceding term. Maybe add that if you didn't catch that quickly. So it's really, the term is just any term you pick. Any term you pick. So let's pick 8. I'm going to put 8 on the top. What goes on the bottom then?
4.
4. So this, in essence, is just our A sub 2. Here's our A sub 1. It's always just the term divided by the term that comes before. That allows us to see that R is 2. Right? Okay. Now, when we're figuring out what R is, it's going to be important when we get to graphing that we test it 3 times. We have to test it 3 times. Because we're going to deal with, if it was arithmetic and it was just adding 4, adding 4, adding 4, adding 4, it would be a straight line. Right? That's a straight line. if it's geometric, what kind of curve or function are we going to see? It's going to get bigger pretty quick, right? It's going to be more reflective of an exponential function. Okay. So here's the deal. If I have 2 points right here, if I figure out, oh, my r is 2, I'm guessing from these 2 plotted points that is this going to be a line or a exponential? Or could it be both? We don't know. What do we need? We need that third situation to confirm it. Third situation. We have to find r 3 times, because if we find values for r, and you know these are a sub 1, a sub 2, and we have some kind of growth up. These are just values. We'll just say this is well, let's say that's 7 and that's 9. Okay. Doesn't matter what numbers are involved. I need a third point to see if it is a exponential versus if the third point is here, it's arithmetic. It would be a line. Okay. So all I was trying to show you a rationale. If you say, well, why do I can see it's 2 for all of them? Why do I have to test it 3 times? Because it won't always be apparent, and you have to test it 3 times to know for sure when you graph it that it's exponential, which reflects a geometric sequence. Okay. So what else should I test? I did 8 and 4. What should I do? 16 and the one prior? 8, 2. Okay. How about then we go with 32 and what? 16. What does that give us? 2. So we have 2, 2, 2. We know that it is, the ratio is 2. So you have to know the ratio first. When we get into practice problems like this, I mean, it may be helpful to actually do that out to confirm it. And I'll ask you to do it out. Either way, even though you can see it's 2, knock it out 3 times, it's quick. I'm going to have you create your own. Create your own sequence real quick. Start at 1. You're going to choose an R, and then go ahead and just fill in 3 other boxes. Dot, dot, dot.
Can I volunteer mine?
Is it going to be a really good one? No factorials. It has to be a value for R. Okay. You want to volunteer right now to show yours? Okay, do it.
1.
No. I mean,
Oh.
R can't be 1. Is that where you're going?
No, it starts off with 1.
Okay.
So it's going off with 1.
Okay.
Right.
Yeah.
My R was 1. You'll have to write down 4 numbers. Oh, that's so fun.
Oh, God. Arthritic from Fortnite. Oh, my thumbs.
Whoa. No.
No. Fortnite doesn't give arthritis.
That's a weird quote.
Okay, I got it.
It's like falling on stable icons.
Alright, so mine is, if you want.
All right, here we go. Let's bring it back. Finish up your sequence. Gene has volunteered to give us our R first. What's R?
Oh, no, I want to tell you. I want you to
You want us
figure
to
it out.
guess. Ooh, mystery man. All right.
So, 1.2.
Oh, 1.2?
No. 1, 0.2.
Gotcha. 1.2. No.
Yes, and then 0.04,
0.04.
and then 0.008.
0.008.
I wonder.
All right.
But you can-
First, can anybody see it? Can anybody intuitively just see it without having to do the fraction? Anybody see it? Jackson, what's our R?
Isn't it just 0.2?
I guess that's the easy way to see it. Why is it 0.2? Because it's 1 times that value.
Yeah.
Your second term, if you start with 1, if it wasn't as started with 1, actually for next period they're going to start with like 7. Oh, the honors class got the worst one. R is 0.2. So let's look at this. We start at 1. This is actually a clue. We start at 1. We end up with 0.08. Why is it reducing in values as we go through the sequence? Why? Yes?
Because you're multiplying by a number less than 1.
Perfect. Okay. I was going to get that point over here. I'm going to say it again. When I do it over here, you got to pretend like you haven't heard it.
Okay. It's on camera.
All right, here we go. Put it right here. Nah, it's better. Okay, this right here, recursive, is everything we've just spoken about. Let's look at this together. A sub n. A sub n, it's saying whichever term you're looking at. Term 2, term 4, term 8, doesn't matter. So let's just do it for the second term. Let's see. So A sub 2 is equal to, right? Since n in this case is 2, it's going to be 2 minus 1. What's 2 minus 1?
1.
Times r. Does everybody agree that the second term is the first term times r?
Yes.
Does that totally make sense? Okay. That's all the recursive, the logic to the recursive formula is. It's just saying that the next term is equal to the term prior times r. Good? Good with that? Okay. So now let's look. This is what we're going to do to find the next term. When you're finding the next term, use recursive. You can use explicit for everything, but when you're looking just for the next term, recursive is quicker. Find the missing terms. Okay, first let's label it. What goes first? A1, A2, A3, just so I can refer to them quicker. A5. Find the missing term. What do we need to know first in order to find what increment we go from? Not increment. What multiplier we go from A sub 4 to A sub 5. We got to figure out the ratio. We got to figure out the ratio. How many times do we have to confirm it? 3 times. So let's see. Let's go ahead and figure out the ratio between 3.6 and 1.2. 3. All right. Let's go between 10.8, 3.6, 3. Let's do it with r is equal to 32.4. 10.8 is? All right. 3 3s. Coincidence. But 3 of the verified common ratios are r. We know for sure is 3. What do we do with that information now? You could just say, well, I'm going to go in here. I'm just going to take the last term and just multiply by 3. And that's fine to think of it that way. We have to express it. You can't just put the answer. I don't know how you got it. So I'm going to do it this way. We're looking for the missing term, a sub 5. It's going to be equal to 5 minus 1, so the prior term times r. Right? Now you have a map. Now if you get the wrong answer or something goes askew, you know where and how you were kind of strategizing it. So even if that's the rationale for writing down something extra, put this here to get started, and now we can just fill it in. We know that a sub 5 is going to be equal to 32.4 times 3. Okay, what was that, 97.2?
Yep.
A sub 5, 97.2. Okay. Thumbs up, sideways down for this first part. Okay, it's been almost a total thumbs up day. Second part has a little bit potentially around here. We'll see though. We'll see. You're period 5 after all. All right, explicit. You can find any term. So I'm not sure how far Evan got to get to the 2 times 2 times 2 times 2. Take a guess. How far did you go? What term did you get to? 15th term. 15th term. Yeah. So if you wanted to know the 83rd term in that sequence, would you be able to finish it on the car ride?
Yes.
Depending
Yes.
how long you drive.
Good point. If it's like a 15-minute car ride?
They're driving to school.
Yeah. So it would be a real hassle to go through every single level and find it all the way down to the 83rd, a sub 83. So in this point, in this method, we can find any term. This is key. Okay. So there's 2 different approaches. We're finding any term here. So find the specific term, a sub n, given this. A sub 1 is 128. Our r common ratio is 1/2. N is equal to 8. All right. So I want to go over here and just map out what I'm going to do. I'm going to go ahead and go with a sub 8 is what I'm looking for. We have to know what a sub 1 is. Multiply it by r to the 8 minus, in future, 8 minus 1. You see how I set that up? I use the recursive formula. I know I'm looking for the nth, the 8th term. N is 8. Kind of looks like a infinity that is almost an 8. Kind of looks like a 9. So we have the 8th term is going to be the first term times our ratio raised to the power of 8 minus 1. So let's now fill in the blanks for this. Let's put in a sub 8 is equal to 128. 1/2. What is 8 minus 1?
7.
7. It's not the hardest arithmetic you have to do. It's 2. And what is 1/2 to the 7th power?
1/40.
Good.
It's 1.
1.
So we get an answer of 1. 128 times 1 over 128 is 1. So a question you've never heard before. How come if the first term is 128, why is it that the 8th term ends up being 1? It's supposed to get bigger. What the heck? Luke?
And you don't know.
Genius. I think that is Starburst worthy, and you're in the perfect position for me to redeem. You'll get one too. You're gonna. I'm gonna redeem. Ready?
Oh.
There's a beam.
Never been more hurt.
It's okay.
Oh.
Good try. Wait, from there.
Next time. That was a good suggestion. Can't stop the film factor. Thumbs up, sideways down for using the explicit. Pretty good. All right. One other thing. What if instead of the first term, what if this was the second term? Think about it. How do I use the explicit formula if I needed the first term, but I'm given the second term? Gene.
Well, so what in we can't well. We know the second term, so we basically use a formula for the recursive thing, right? So you're going backwards, so you multiply 128 by 2, which is a number.
Okay, I see.
And then that's A1, and then you do
And then go to this one.
yeah.
Perfect.
Yeah.
Sonia, you have a difference? That's actually right, but can you explain?
I was just going to say that 2 is like the reciprocal of the
Interesting.
R.
Of 1/2.
Of the ratio.
It's true. It's true. All right, I'm going to show the mathematical way to do this. When you get to number 5 in the classwork, you're going to see this kind of thing is going to happen. So I would go like this. I'd say, well, I know that a sub 2 is equal to a sub 1 times r from my recursive. Right? Everyone agree? I know that a sub 2 is 128. A sub 1 times my r is 1/2. Right? I'm just solving it out. I'm going to multiply by 2 over 1. By 2 over 1. So I use the recursive right here, knowing that I have the second term, in order to find the first term. You can also go backwards. You solve for what you don't know. You isolate it. That cancels it out here. We have a sub 1 is equal to 256. Okay. Now I'm ready to go. If this was a sub 2, I changed that. But if it was a sub 2, then we'd have to find a sub 1 before we can use the explicit formula. Make sense? It did already, huh? I'm saying for those at home, for my viewers in Brazil.
So let's say that is a sub 3.
You know it. What?
That is a sub 3 is 121. Would you want us to do basically that step twice, or can we just do 120 times 4, which would be multiplied by 2 times?
If you had the third term, I'd actually use the explicit to find the first if you knew the ratio, because it would be the third term is equal to a sub 1.
Or you do it 3 times?
That'd be the very.
You could do it. I used the recursive because I was just looking for the term before it, but I would solve it this way. If I have the third term, a sub 3 is equal to a sub 1 times r, 3 minus 1. You could work it that way as well. Just know that you're going to plug some things in and work backwards sometimes. It's no big deal. It's just algebra. Anyone have any good closing encouragements to all my YouTube subscribers. All 163. I haven't got a new one
Did
in
you guys all
2
vote?
months.
Did you guys all vote?
Did y'all vote? Waiting. No, about 25% of you did. Dang.
Loud.
But most of them are kids, so it's even less.
Yeah, because we can't legally vote.
Loud like this.
We could illegally vote.
If I could.
1, 2, 3, illegally vote? No.
My parents-
Let's go with 1, 2, 3, recursive explicit. That's kind of cool. 1, 2, 3, recursive explicit. 1, 2, 3. I kind of messed it up.
Subscribe.
Yeah.
And subscribe,
I got
please.
a good idea.
Starburst thrown around the world for you.